Today we're going to graph absolute value functions, and we're going to explore what they look like, and we'll use the graphing calculator to help us. So this is also an intro into a few of the features of the graphing calculator. So ultimately, on this first graph, we want to graph this equation. Y equals the absolute value of x. Anytime you're going to graph something in the graphing calculator, you're going to enter the equation in this y equals button. So everyone press y equals. Another helpful thing to know, this calculator that I have up on my screen, the last button I push is always highlighted in red. So if you look up and my screen looks different from yours, look for which button is red. That'll tell you what button I just pushed to get to that screen. Okay, now these calculators, the ones that are in my room at least, are used by several people throughout the day. So there might be stuff in this screen. So if you see any stuff in here, push clear and clear it out. You might have to go down to other lines and clear out other lines. The other thing I want you to look for is right along the top. See where it says plot 1, plot 2, plot 3. Mine has plot 1 darkened. That means that there's a stat plot, there's a statistics plot turned on in my calculator. If I try to graph with that stat plot turned on, it gives me this error and it won't work. So that stat plot actually does really affect your graphing. So if you see that any of those are darkened up at the top of the screen, use arrow up to go up there and push enter, and that will turn it off. So do you see how those 3 plots are now not darkened on mine? You want your plots to look like mine. Okay, we want to enter y equals the absolute value of x. So on this version of the calculator, the skinny version or the color screen version, we are going to push math button. In the math button, there's tons of options. There's 5 menus to choose from. We want to use the right arrow to go over to the number menu. So right arrow over to NUM. And then the very first option is ABS. ABS stands for absolute value. So push enter to select absolute value. If you have a newer calculator, it will pull up the vertical bars and you'll have a spot to stick your whatever you need to stick in there. If you have an older version of this calculator, it might say ABS parentheses, and you enter the stuff inside the absolute value bars inside those parentheses. X. A lot of you might see that there's letters all over this thing. We do not need to push the alpha button to get X. There's a special button for X. It's right next to the alpha button. It says X, T, theta, N. That's your X button. That's the button that you use to enter X into an equation. Anyone want to guess what we should push to graph it? Enter. That just moves it to the next line. Graph. There's a button that says graph. So we push the graph button. And I'll tell you what, the calculator on my screen graphs a lot faster than yours does. The only thing that this calculator does slow is start up for the first time. After that, it's like Speedy Gonzalez. It just, it's totally graphed. So this is an absolute value function. Absolute value functions are symmetrical. How would you describe the shape? It's a V shape. Basically, if x is negative, like -5, it turns it into a positive number, +5. So there's nothing negative on this graph. It's all positive numbers. Now, here's what you should not do. All right, my calculator graphed it, so I need to put the graph on here. So there we go. That's close enough. No, don't just sketch the graph. If you let the graphing calculator graph it for you, you need to accurately put this on your paper. And the best way to do that is to get some points. Right above the graph button, what does it say? Table. Push second graph button, and it pulls up a table. This is a table of points. You can now use this to plot points on your graph. Now, right now, mine shows the points from -6, 6, all the way to 4, 4. What if your screen looks different? The up and down arrows will move you along that table to different points. So you can always move this around to get points that you want. So I'm going to plot the point 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3, and so on. There's our graph of our absolute value function. What if you push the graph button and you look at the graph and you're like, this is not right? I want you to learn Zoom 6. This is called Zoom Standard. If you push the Zoom button, which is right in the middle under the screen, and then push number 6, option number 6 says Z Standard. Zoom 6 will reset your graph to a normal negative 10 to 10, negative 10 to 10 screen. So if you look at your graph and you're like, hold on, Zoom 6, that should fix things. If you get an error, if you try to graph and it says error, go back into y equals and see if one of those plots was on the top, because that's usually what brings you the errors. All right, let's graph y equals 2 times the absolute value of x. So go into your y equals. And I would just clear it out because we want to practice entering this anyway. We want 2 times the absolute value of x. So 2, how do we get the absolute value? Math over 1, or over enter, math right enter, and enter our x, and graph. Now, you may not notice the difference on this graph because this is actually kind of like a widescreen. Do you see how the boxes on your graph are actually pretty wide? You're really going to notice when you go into the points and you graph it on your graph paper. So second table, and let's get some points. We got 0, 0, 1, 2, 2, 4. Second graph to get to the table. Second graph to get to the table. This graph appears to be more narrow. I don't think narrower is technically a word, but in this room it's going to be a word. It's more narrow or steeper. Another really good word is steeper. Look at the number in front of the absolute value bars. 2. Look at the number in front of the absolute value bars on number 1. It's a 1. From the vertex, that point where it changes direction is called the vertex. In fact, it might be a good idea to point at that and say, hey, that's the vertex. From the vertex, the original one in number 1 goes up 1, out 1, up 1, out 1 to make that V shape. In number 2A, it goes up 2, out 1, up 2, out 1. So that number in front of the absolute value bars, it kind of works like a slope. It's like the slope of the right side, and then the left side is a reflection of that. So if you want to think of that as the slope, that's a good way to kind of think about it. A steeper slope is going to make a narrower absolute value function. What do you think 1/2 times the absolute value of x is going to look like? It's going to be wider. It's going to go up 1, out 2. So honestly, right now, could you probably just put the dot here, up 1, out 2, up 1, out 2. If you did that, your graph would be correct. You could check this using the graphing calculator, but what you're already noticing about those absolute value functions is absolutely true. That number in front of the bars acts like the slope of the right side. The left side is just a vertical, like a reflection over a vertical line. What do you think is going to happen if we put a negative in front of the number? Any guesses? All right, since there's no guesses, let's try it. -2, absolute value of x. Instead of a V-shaped valley, it's now a mountain. It flipped this over the x-axis. So now you've got The vertex is still at 0, 0. It didn't move the vertex, but now it's down to out 1 to get those points. So let's take a moment. What effect does a number multiplied to the absolute value have on the graph? They're talking about this A value. If there's an A value in front, if that A value is negative, the graph opens down. If the A value is positive, it opens up. So down versus up. We also notice that larger numbers make narrower graphs. So if A is larger than 1, it's steeper or more narrow. If A is smaller than 1, like a fraction 1/2, 1/4, whatever, it is wider, or that right side is less steep. Okay, we're making guesses about what this -3 inside the absolute value bars is going to do. Absolute value of x -3. You want to make sure that that -3 is inside your absolute value bars. And then graph. It shifted the graph to the right. How many units to the right? 3 units. This one still has a slope. It's not really a slope, but we can kind of think of it as a slope of 1. But I want you to write next to here that this shifted the whole graph right 3 units. Is it kind of weird that -3 shifted it to the right? It's kind of backwards. So what do you think a +3 is going to do? It's going to shift it left 3. And if you want to take the time to check that, you absolutely can. But if you trust me that it shifts it left 3, you can trust me that it does shift it left 3. Basically, what you want to remember is that whatever happens inside those absolute value bars is kind of like backwards crazy town. Plus moves it left, minus moves it right. So in this next little thing, what effect does the number added or subtracted? Added inside moves left. Subtracted inside moves right. And you might want to note that it is backwards of what you would expect. So next we need to talk about adding or subtracting outside of the absolute value bars. Adding to actually shifts this up 2. So -2 is going to shift it down 2. Do you see how up and down movement are completely normal? Plus, up, minus, down. So at the bottom here, plus, up, minus, down. You might want to add that this is what you would expect. That's normal based on what you would expect. Inside the absolute value bars, crazy town, backwardsville. Outside of the absolute value bars, perfectly normal. Let's sum up everything that we've learned. I want you in this space here to write in y equals a times the absolute value of x minus h plus k.